Hey everybody, today I'm going to do a little repair. Actually, this is my son Aidan. Aidan, say hello to everybody.
Hi.
How old are you, Aidan?
11.
Aidan's 11 years old, and he's got a toy RC car here that he likes a lot, and had a little bit of a mishap, and ended up breaking one of these wires off, and he asked me if I could fix it. I explained to him that what needs to be done is it needs to be soldered back on, and then I thought about it and I said, well, maybe I'll teach him how to do it and he can actually do the repair himself. So we're just going to do a real quick little repair on this RC car. Should be pretty simple to do, and so I'm going to get a close-up shot of the repair we need to do, and then we'll go from there. Alright, so this is a RC car by Traxxas, and it's called the Traxxas. And it's a little bit smaller than the bigger Traxxas RC cars. But the problem is this wire right here goes to this terminal on the motor right there, and it broke off. What happened is this is the battery connector here, and you have to squeeze this clip right here to separate the battery, and sometimes it's a little tight and you got to kind of pull on it. And somehow when he was pulling on it, he thinks maybe his finger caught on this or something, and not quite sure how it happened, but basically this wire broke off of here. So what we're going to do is we're going to try and reattach it to here. So we're going to have to strip this wire insulation back to expose some new wire. This is plenty long enough, so we shouldn't have to worry about that. But it looks like what they do is they either wrap the wire around this post, or they put the wire through a hole in the lug on the motor and then solder it. So we're going to need to try and clean that up first. So here's a little bit of a tighter shot, and you can see this actually the connection goes right there. Okay, so there's a few ways that you can solder, and really what tools you're going to use to do the actual soldering. A lot of it has to do with what you're actually going to solder. Okay, so for instance, you know what a blowtorch looks like, right? The little handheld torch, the little bottle of gas. Okay, well, if we were soldering copper pipes together for plumbing, we need a lot more heat, so we would use a torch with a big open flame to heat those pipes up to get the solder to actually stick to the pipes. Okay, because soldering is not like, it's a little like welding, but it's a little different too. Soldering, the easiest way to explain it would be soldering is almost like we're gluing with metal. It's almost like we're using the solder, which is a type of very soft metal. We're using that almost like a glue. Okay? And to get the glue to flow, we need to heat it up to the point where it melts. So solder melts at a lot lower melting point than the metal that we're soldering to. Okay? But if we try to use like a torch, for instance, on this, we would we'd melt the motor, and we'd melt this, and probably catch this whole thing on fire. So we obviously don't want to do that, right? Okay, so then we want to use an electric soldering tool, and we could use a soldering gun, okay? But you know what a soldering gun is, right? That's that black thing that's got the trigger you pull, and it's got the two wires that stick out and they come to a point. Soldering gun is good for doing electrical solder work on like large connections, things that are going to take a lot of heat. What we want to use is what's called a soldering pencil, or more commonly probably called soldering iron. Okay, so this is a small one. All right, this happens to be a WLC 100 model. This is a Weller, which is one of the most well-known names in soldering irons. They were making these when I was a kid, so I think they've been around for quite a while. This one's got a little bit of an adjustment on it. It's not a really fancy one. The really fancy ones have digital readouts and actually can tell you the temperature at the tip with a digital readout. You know, it can actually tell you what the temperature is. This one here has just basically got a 1 to 5 setting on it, so you can set it all the way high for soldering larger connections, and you can set it lower for really delicate work. But enough about that. So the first thing we need to do is we need to get the soldering iron heated up. It takes a few minutes for for it to heat up. So we're going to plug this in and we'll get it going. Okay, so you can go ahead and turn the soldering iron on. It's that switch. Alright? So when you first turn it on, it's not hot instantly. It takes a while to heat up. But the thing you got to remember now is now that we turned it on, it's going to heat up. It's going to get very hot. Okay? So you got to be careful because you don't want to get burned. Basically, it's safety. Okay? Hot. All right, that's already hot. I can already feel the heat coming off. See, they put this little wire holder the way they make this, and so that nothing can come directly in contact with the actual torch when it's in there. So if you accidentally, like we're reaching for something and you hit your hand near it, you're not going to get burned. However, if I take this out of here now, okay, see this little black part right here? From basically that point up to the tip, that's all burning hot. If I touch that with my finger, I am going to get a very bad burn and my finger will blister and I will be very sorry that I did it. I will feel very stupid that I did it. Okay? Don't feel the need to touch that.
How would I?
Why would you? Not intentionally, but even absent-mindedly. You know, if something, for some reason you put it down like that, that's not good, okay? We always put it back in the holder, all right? Because you never know what this could come in contact with. You turn around, you know, talking to somebody, next thing you know, it starts melting plastic and could even cause a fire, actually, okay?
Yeah, because it's...
Well, this probably, you can see there's actually some burn marks in this. It would be very hard for it to catch this on fire, but let's not find out. All right?
Mm-hmm.
The other thing about soldering is you should wear safety glasses when soldering, okay? So, for instance, a good pair of high-quality safety glasses like this is a good idea, okay?
I have glasses.
You have glasses, and for the purpose of soldering today, those glasses will suffice, provided you're not wearing them down on the end of your nose and looking over them.
Like Mark.
Mm-hmm. Yeah, like you too. So, why do you think we need glasses?
Sparks?
Sparks? No, we shouldn't be seeing sparks from this. No, what can happen is sometimes if there's any moisture present, or sometimes just for no explainable reason, you'll suddenly have a situation where a blob of solder will have a bubble in it, and the heat from the soldering will actually cause that bubble to expand, and the air or whatever gases are in there will expand violently and cause the bubble to pop. So just like if you were blowing bubbles and you pop a bubble, you ever been blowing bubbles and when one of those bubbles pops, you get sprayed with a little bit of the dishwashing liquid or the soap liquid? That little tiny bit of liquid hits you because the bubble popped and it went flying, okay? Well, if a solder blob pops, okay, that molten hot solder can go flying, okay? And you can end up with it hitting you. And if it hits you on the hand, it'll burn and it'll hurt, but you'll live, okay? And you won't have any permanent damage. Very rare that you would even get a scar that would last, okay? However, you get a blob of that solder goes flying and goes in your eyeball, you could be blind. It could blind you, okay? And when you think that, that probably never happens or whatever, I'll tell you right now, I have seen, when I was in electronics at the Voctech school, okay, when I was, not much older than you, I've actually seen kids that ended up with splatters of solder on their glasses, which is obviously means that if they didn't have the glasses on, where was that solder going to go? Right in the eyeball, right? Okay, so that's important to know, that we're going to make sure we use safety glasses. I'll wear these because they got the tag hanging off them.
It'll protect your nose.
Yeah, protect my nose. Right, okay. So, the other thing we want is we actually want a little bit of water. You see this is a sponge that comes with the holder, okay? And see it's got these slots in it?
Mm-hmm.
And the idea is that when we wet this sponge and we put it in the holder, we can actually wipe the tip of the soldering iron when it's hot on this sponge, and it helps clean the tip. The reason why we want to clean the tip is because if you have any crud on the end of the tip, like you can see there's some stuff on there from last time this was used, okay, that can actually cause a problem, and you end up with impurities in your solder connection. You also, it can also affect the way it transfers the heat, So let me just get a little bit of water.
I can do it.
Yeah? All right, go ahead.
Right over here.
Okay, go ahead and take the soldering iron out and wipe the tip on the sponge. And then just flip it over and wipe it the other way. Yeah, roll it over so you get both ends of it. And you don't have to do it so gently. You can do it. What I mean to say is,
I already got it.
put it back in. Put it back in the holder.
Holder, okay.
Okay. Okay. This is also, by the way, that just reminded me of something. This is also often referred to as a soldering pencil. Okay. And the reason why I'm going to call it a soldering pencil right now is because it just reminded me that that's how I want you to hold it. See how this is got this black part around here? Okay? You're holding it kind of like this. You never want to solder like this, okay? You want to hold it like a pencil so you have more accuracy. I'm left-handed, so I'm going to hold it like this. Okay? See how I'm holding it? Kind of like the way you would hold a pencil. So I could actually write with this, right? So go ahead. Pick it up with your right hand, hold it like a pencil. There you go. That's better. Okay, put it back in there. Alright, so what we're going to do next is we're going to strip the wire. Actually, we could desolder it. Let's desolder that first. Alright, so you were asking me how we desolder. Or, well, unsolder it, but we call it desoldering. The process of actually removing the old solder so that we can reattach the component. Okay, so there's a couple ways you can do it. They actually have special soldering irons that have actually suction built in, like a vacuum pump built in, and you can actually put the special soldering tip right on it, and then you press a button and it sucks the molten solder right up and collects it in a little jar. And that's really nice if you're doing a lot of desoldering, but those machines are more expensive, so most people don't have those unless they're like in the business of doing that kind of work all the time. So the other way you can do is you can have a mechanical type of vacuum pump like this here. This is a desoldering tool. Okay, this one's, I don't even know who makes this because the name's worn off. I've had this so long, which goes to show you this is actually a pretty good one because I've had it a long time. But the way this works is there's a spring in here. This is spring loaded. When I push this down, kind of like I've cocked it, you know, like a gun, and this is the button that releases it. And when I do that, what happens is the spring-loaded plunger that's inside here moves up really fast, and what that causes is that causes a suction on here. So if I actually put my finger on the tip here and I release it, it actually goes up a little slower because it actually pulls up on there. You can actually feel a little bit of suction. Put your finger on the tip, it won't hurt.
Yeah.
You feel it just kind of gives it a little tiny suction on there. So the way this works is you get it ready and then you heat up that area right there with the solder on it. You get this really close, okay, and then when you start to see that the solder's melted, you push this button and hopefully it'll suck that ball of solder right up. And then the solder collects in here, and if you push this down, if you push it a little bit further, see?
Like this.
Yeah, well that was actually in there. See, watch, when I push this down, see the tip comes out a little further? That helps eject any solder that might be stuck in there. So that's probably left over from the last time that I used this. Alright? So that's one way of doing it. And then another way to do it is to use something called soldering braid or desoldering braid or desoldering wick. And the reason why they call it wick is because just like the wick of a candle will actually soak up the wax. Okay. Well, this special copper braid, if we looked at this, it's got a little mesh to it. And the way this is designed, when we heat this up and we put it in contact with the molten solder, this will actually want to wick up or kind of like draw the solder into it. Okay, so the solder will want to leave where it is there and come into contact with this. So this is really good if you got like one little point that you want to desolder. You would actually put this right over the point. You put the soldering iron on the back of the wick to heat the wick up. Once the wick gets hot enough to melt the solder will actually draw right up into this. And then, as this gets filled up with solder, you have to periodically cut it back. That's why it comes in a roll like this. This works pretty good. Now, the other thing too, I say this works pretty good, but I've noticed that there are a lot of brands, different brands of this out there, and there are some brands that just do not work very well at all, and then there are some that work really well. So beware of cheap desoldering wick. And this is solder. We'll get to that in a minute. All right, so what we're going to do is we want you to try and desolder this. So the first thing you're going to do, all right, you got to note right here, you see that white thing?
Mm-hmm.
That's a cover that's covering a leg of wire that goes to that little tiny component there called the capacitor. So what that means is we don't have just one thing connected there. Under that solder, there's actually this capacitor right here. It's soldered to the case of the motor and to that lead. And then this capacitor here is soldered to that lead, and then the other end of it's soldered to the other lead. Okay? So we're going to have to try and clean that up. So go ahead and take the soldering iron, okay, re-clean it because it's been a while. So you're going to do like this, roll it over like that, okay? Now the first thing we're going to do is we're going to take some new solder, all right? We're going to take some new solder and we're going to touch just a little bit of it to the tip. See that?
Mm-hmm.
Okay, that's called tinning the tip. What that does is that molten blob of solder there now is going to make a really good connection with this blob of solder, and it's going to help transfer the heat and help that melt quicker. So go ahead and put that on there. All right, but you see you're touching the side of the solder we don't have the blob on, so kind of put it underneath it. There you go. Now just hold it on there. There you go. Keep it on there. Don't move it. And since you're new at this, I'll do the desoldering. I'll work this for you. You want to try and... You're moving it around too much. No. Don't go fishing for that blob of solder with the... You're just going to melt the plastic if you touch the... You don't want to touch the plastic. Go ahead and try it again. Hold it on there. Didn't really get much that time. There you go. Keep it right there. Don't move. I think we got some that time. There we go. See? Little piece came out.
Is that hot?
Yeah, it's hot.
No, I did. No, I got some there.
All right. I think we got quite a bit. Go ahead and put the soldering iron back.
No, we got a little bit.
Yeah, you removed some of it, but we didn't remove all of it. So let me get a shot of this. Put my soldering glass, my safety glasses on. See, that's a pretty good sized piece of metal that that lug is made out of. So it's drawing a lot of the heat from the soldering tip away before it can melt the pool of solder well. Let's try one more time with this. Yeah, it didn't really get much. So now I'm going to try the soldering wick. So the soldering wick, I'm going to hold the wick right over the top of it, okay, and then I'm going to push down with the soldering iron. You see the end of the wick? You see how it's changing to the color of the solder?
Mm-hmm.
It means it drew some of that solder in. So I'm just going to take this magnifying glass that I have here and I'm going to look at it really close to see if I can see what's going on here. And actually it doesn't look too bad. So I've got the little hole almost completely exposed. So this is bent a little bit back. So I don't know if you can see that or not, but there's a tiny hole right there.
Yeah.
You see it?
Mm-hmm.
Okay, so that's what they've got the wire was going to, but it's kind of crazy because it's not not very big at all. In that one little tiny hole, they've got 3 leads. They've got the lead for one of the capacitors, the lead for the other capacitor, and then the lead for the wire is supposed to go through there. Let's see how thick this wire is. Okay. So what we're going to do is I'm going to strip this wire. So what I want to do is, you see each one of these little teeth is for a different size wire. Okay. So I don't want to strip off too much of the insulation. So I'm just going to go back to about there. Okay. And then what I like to do is I like to, when it's hard to hold the wire without ripping it, I use the pliers. I clamp it like that. And then I can pull that off. See? See how I pulled that as it cut? And by holding it with the pliers, I wasn't ripping on this whole cable, okay? So now we can get an idea of, we can see the wire. Now the problem is, if you look at it, that's actually pretty thick, that wire. I don't think they even had that going through that hole. I think they may have just attached it with a blob of solder. Because I can pretty much see that this is not going to fit through there, even if we cleaned up the hole even better. In fact, I don't even know if that would fit through there if we, well, that's what we can do. I'll put my glasses back on.
You want me to solder it on?
Well, let me see if I can get it through the hole first, okay? If I can get it to go through the hole, then you can add some solder to it. No, I don't think that's going to work at all. But I don't think we're going to be able to get that to fit in there at all. Alright, that looks pretty clean now. You see how the hole, you can see the hole's nice and round? Do you see it?
Mm-hmm.
But
you can't fit it through.
Not going to fit through, is it? No. So, I don't know what they were thinking when they made this, but it's a design flaw, to say the least. So what we're going to have to do is we're just going to have to put a blob of solder on here, a blob of solder on there, and then have the 2 blobs get together. Okay? So, first things first. I'm going to tin this again. Do you see how that's got like a flat side to it? So I'm going to put a little blob of solder on there. Now,
what would you touch the wire?
Touch that. Hold this up under the bottom of that. And hold it right on there. Okay? And what we're trying to do is we're trying to get the wire hot enough so that we can get the solder to melt onto the wire and not the iron.
It's on.
Alright, pull it off. You don't want to overheat it. Okay? Alright, move your hand. Move your hand because I want to wipe that blob of solder off of there. Okay? So, not the prettiest, but it'll work. Okay? Now I'm going to put the one on here. See how I get a blob there now?
Mm-hmm.
Okay, so now what we're gonna do, okay, is I'm gonna heat that blob up, and you bring that wire in and touch it against the other blob. There you go. Right there. All right, now don't move. I took the heat away. It takes a second for it to cool off, for it to become solid again. Alright, now you should be able to let it go. And that should be it. Should be done. Okay? That's it. It's all done. Now, the only thing you got to worry about when you're doing something like that is if that electrical connection is right next to another connection, you want to make sure you don't accidentally flow that blob of solder between 2 connections that aren't supposed to be connected. Sometimes they're really close together. Okay? And then it'll short out. In this case, that connection right there is separate from the case of the motor. You follow me? So if we had put way too much solder on there and flowed it and it was touching and soldered to the case, that would be a short. That would be bad. It wouldn't work. In fact, it would be real bad because it would be a short on the output of this controller, which could damage the controller.
Daddy, do you want to see if it works?
Yeah, sure. Hold on. All right, like for example, see this is a printed circuit board, okay? So all of these components have leads that stick down through the board, and then on this side they're soldered. And they're soldered to these light green areas, which they're light green because they're covered with epoxy, but what's underneath there is copper. Excuse me. So if I take this utility blade and I scrape this, there you go. See it? See the orange copper? So that's a thin layer of copper that acts like a wire. So for example, if you look at on here, if you look at see that connection right there, that little connection there, that's a couple of wires that are coming from a component on that side, okay, that are sticking through the board, and they're soldered to this layer of thin copper. This layer of thin copper, you can see where it goes. It goes way over here to some points, and it comes over here to some points. So it's acting like a wire. So it's making an electrical connection between here and here and here and way over here. But you can see there's a bunch of really small ones too. Like here's one, it's got a connection here, and it goes way over here to this one. But it goes past these other ones without touching them. You see it? Mm-hmm. And then look at these. Look how close these are together. You see how close these are? Mm-hmm. Okay, so that's an example of like where it gets really tricky. If I come in here and I soldered, say I was soldering these connections, and I soldered this connection, I put too much solder on there, and the hot solder flowed over and touched this next pin next to it, all right, we'd have solder bridging the connection between these two pins. That's called a solder bridge. Okay, that would be bad. If it's not, if these two are supposed to be not touching each other, and then you put the electrical connection there by solder bridge, that's bad. Okay, you can have a problem. Lots of times when you're working on a project or something and you're not wondering, and you're wondering why it's not working, sometimes you got to go back and look with a magnifying glass and see if you missed something like a solder bridge.
Daddy, why did you solder this?
That, I don't even know if I did that. That might have been, that's probably wasn't me. That was probably somebody else at some point. This board's been around. That board's been around. It's an old one.
But what was that from?
Junkie hot tub. All right, go ahead. So you hook the battery up, you press the button, that turns the controller on. Just lift it up and there you go. Works perfect, right?
Yeah.
We know it works because that was the connection to the motor. So if it wasn't correct, you wouldn't get anything. It wouldn't work at all. The steering might work, but the motor wouldn't run. All right? Mm-hmm. So I believe it's all set. So what do you think about soldering?
It's cool.
It's cool? Do you think you would like to work in a factory where they soldered stuff all the time?
No.
Well, good, because you'd have to go to China to probably do that. A lot of the soldering and production work is done by machines now, so not a lot of the, probably some of the really fine work on high precision stuff might still be done by hand. I don't know. But years ago, it was the only way you could do it, really. I mean, you had to solder it. It was all the components were soldered by hand. Okay, that's it. Say bye, everybody.